Hello guys, welcome back to my expansions. Today we'll be answering questions based on Newton's laws. So I'll start by showing you the questions. I think it's best that you start by attempting them and then you watch the video on how you can solve them. Hello guys, welcome back to my expansions. Today we'll be doing a physics topic based on Newton's laws. We're going to start with question 1. And our question 1, we have a statement here. It says two blocks of mass 20 kg and 5 kg respectively are connected by a light inextensible string P. A second light extensible string Q attached to a 5 kg block runs over a frictionless pulley. A constant horizontal force 250 Newton pulls the second string as shown in the diagram below. The magnitude of the tension P and Q are T1 and T2 respectively. Ignore the effects of air friction. So this is our diagram, and we have a force of 250 newtons, and this is our string T2, and this is T1, and this is block P and block Q. So first question says states the Newton's second law in weight. So for Newton's, this is our Newton's second law in weight, and it says when a resultant or a net force acts on an object, the object will accelerate in the direction of the force at an acceleration direct proportional to the force and inverse proportional to the mass of an object. And for 1.2, we are required to draw, or say 1.2 say draw a free body diagram indicates all forces acting on the block 5 kg. Okay, and then we are required to draw a free body diagram, and the free body diagram for all the forces acting on the 5 kg block. So this is our 5 kg block, block Q. So our free body diagram would be like, and then we have a force acting up, which is T2. So we have here T2, and also we have T1 acting downward, and then we also have the weight. So I said we have weight and also have T1. So our free body diagram was something like this, and this is T1. Okay, this is T1 and this is T2. This is our weight. And when we go to our 1.3, our 1.3 says calculate the magnitude of the tension T1 and the strength P. So now we are going to calculate the magnitude of the tension T1. So we have, okay, so it's always best to draw both free body diagrams for the both objects, even though you are not required to when calculating. So let's first draw a free body diagram for block P, which is 20 kg, and then this free body diagram will be like this. We have T1 going up and we have weight going down. So this is the free body diagram for block P. And we're going to split on and we're going to do calculations for block P on this side, and this side we're going to do calculations for block Q. Let's start with block P. And remember, here's our diagram. So F is our formula sheet. F net is equals to MA. So here, remember that Newton's second law states that F net is equals to MA. And then also F net, sum of all forces acting on object P, which is F net force, is equals to, okay, I said here is T1 and here is weight, and also we must choose our direction, and let's say downwards is negative, meaning all the forces that act down are negative. And then we have forces that act on object P, it's T1 minus the weight. So it is minus the weight because the weight acts downwards. Since we said everything that acts downwards will be negative. And then start, so F net is also equal to F net. So meaning MA is equals to T1 minus weight. And our weight is equals to, remember that weight is equals to mg. So it's T1 minus mg. And our mass for block P is 20 kg, and we don't have acceleration equals to T1. We also don't have T1, of which you are looking for T1, and then minus mass. Our mass is also 20, and G is 9,8 gravitational constant, comma 8, and this is our equation number 1. And now let's go to, okay, remember that I have a product diagram or something like this, and then we're also going to say sum of all forces acting on object Q. Object Q now, it's F net force actually is equals to ma, mass times acceleration. And then we also say sum of all forces acting on object Q, it's F net equals to, it's okay, remember we said downwards is negative, meaning T1 is positive again. Okay, again here it's T2 not T1, so for that T2 in that diagram, and then T1 now is acting downward on, since we are dealing with object Q. T1 here, and we said everything is going down, all forces acting downwards are negative, so T2 is positive, T2 and also T1 will be negative, minus T1 minus weight, which is mg, and here we do what we did on the other side. We say ma is equals to T2 minus T1 minus mg. And then our mass for object Q now. So mass for object Q is 5 kg. Oh, here's our diagram. So mass for Q is 5. So here we're going to have 5, and our acceleration is still A, equals to, our T2 is unknown. Oh, T2 is, we have T2, sorry. So our T2, since this is our force applied, 215, so and here the reflection is 40. So we have T2 is same as force applied, and we have 250 newtons minus T1 minus, and our mass is 5 times 9,8, and then we start solving this side. So we have 5a equals to 250. Okay, we'll just type it in the calculator, and we have 250 minus 5 times 9,8, it is 201. So 201 minus T1. Take this away. Go back here. Remember here we had this equation, so this is our equation number 1, and this one is our equation number 2. Since we have acceleration, this is unknown in here, so we're going to solve for using this equation. So we're going to use material, and since we are looking for T1, we're going to make acceleration as the formula here, so that we can substitute it to this equation, and then we solve for T1. So we're going to divide by 20 and divide by 20 here, and we are left with A is equals to T1 minus 20, or 20 times 9,8, it's 20 9,8 will be equal to 196 all over 20. And then go to this equation again. We make a substitute the formula, and we're going to divide by 5 both sides, and we are left with a equals to 201 minus t1 all over 5. And now, since we have a substitute formula here and here, we can now equate our equation by saying 201 minus t1 over 5 is equals to t1 minus 196 all over 20. And then now we're solving for t1, and then we're going to cross multiply. And when you cross multiply, it starts on this side. 201 times 20, it's 201 times 20 equals to 4020. So it's 4020 minus t1 times 20. Negative 2 times 20 is negative 20 t1 equals to 5 t1 from 5 times t1, and then 5 times negative 196, we're going to have 5 times 1 times 196 is equals to 908, meaning it's minus 980. And we make t substitute formula by taking 980 to our left hand side, so we're going to have 4020 plus 980 equals to 5 t1 plus 20 t1. And then we solve this by saying 4,220 plus 980 is equals to 5,000 equals to 5 plus 20 is 25 t1, and we say divided by 25, we divide by 25, and we get our answer, which is t1 is equals to 5,000 divided by 25 is 200. So 200. Okay, you can use a calculator and say 5,000 divided by 25, you get 200. And our answer would be 200 newtons equals to t1. And now let's continue with another question, still based on Newton's laws. Okay guys, this is our question 2. And our question 2 says a block of mass 1 kg is connected to another block 4 kg by a light inextensible string. The system is pulled up a rough inclined plane at the angle of 30 degrees to the horizontal by means of a constant 40 newtons force parallel to the plane as shown in the diagram below. This is our diagram. And the magnitude of the kinetic frictional force between the surface and the 4 kg block is 10 newtons. The coefficient of a kinetic friction between 1 kg block and the surface is 0.29. So guys, every time when you are attempting to solve a problem based on Newton's problem, you make sure that you read your statement before attempting to answer, because critical details are stated on the statement. Like here, we are told that we have a coefficient of a kinetic friction 0.29 for 1 kg and the frictional force for 4 kg block. If you didn't read the statement, you would have not known this. So our 2.1 says states the Newton's third law of motion. And the Newton's third law of motion says when object A exerts a force on object B, object B simultaneously exerts a force equal in magnitude but opposite in direction on object A. And then 2.2 says draw a labeled free body diagram showing all forces acting on the 1 kg block. So okay, let me draw my free body diagram here on this side. Okay, first this one. Okay, our free body diagram, will draw it here. So in our free body diagram, we'll have the applied force. The force applied and our weight, and this is our normal force, and we have frictional force and the tension. So here it's force applied, normal force is x perpendicular to the surface, and this is the weight pulling the object down, and here is our frictional force, and this is our tension. This is our free body diagram for 1 kg block. This is our 2.2. And then 2.3, we go to 2.3, 2.3, and then 2.3.1. We are required to calculate a kinetic frictional force between the 1 kg block and the surface. And remember that I said we are allowed to use our equation. So since we are allowed to use our formula sheet, this is the formula that we are going to use. And then it says Fk is equals to coefficient of a kinetic friction times normal force. And then we have a coefficient of kinetic friction for 1 kg block. It is 0.29, and our normal force, this is our normal force. Our normal force is equals to weight perpendicular. Okay. This is our weight perpendicular. And then we have weight parallel. And then we have 90 degrees here. And our end here is 30 degrees. This thing here. So since we have this triangle, this is our weight perpendicular and weight parallel. And our normal force is equals to weight perpendicular. And our weight perpendicular is equals to, remember our trig ratio says this is our hypotenuse, so meaning adjacent over hypotenuse is equals to cos 30 degrees, and our weight perpendicular will be weight perpendicular is equals to weight times cos 30 degrees, and our weight is mg cos 30 degrees. And remember I said normal is equals to weight perpendicular, meaning our normal is equals to mg cos 30 degrees. And you can either calculate it here on the side and then come with the answer here. You can just write it here and say coefficient of a kinetic friction times mg cos 30 degrees and substitute all the values here, and we have 0.29 times our mass is 1 and the g is 9.8 and cos 8 degrees. And then we go, you can use a calculator here and say it's open bracket 0.29 times 1 times 9.8 cos 80 degrees, and it is equals to 2.46 equals to 2.46 Newton, and this is our frictional force for 1 kg. And then now we are doing 2.3.2. It says calculate the magnitude of the tension in the string connecting the two plugs. And then the magnitude, we are looking for this tension here. And then let's start by, okay, let me just take this one. Then since we have required to calculate the tension in the string, and this is our free body diagram for 1 kg block. Okay, here it is. And then let's do a free body diagram for the 4 kg block here. Okay, this is 1 kg block this side, and here it will be 4 kg block. We are drawing a free body diagram because it will help us when we are calculating. So free body diagram for the 4 kg block is forces that are acting on the 4 kg block. We have the weight, and the frictional force acting on the side, and then we have the tension and the normal force. So these are the forces that we need for our free body diagram. Let's go and draw it here. Okay, we have a normal force, and our tension, our weight taken downwards, and our frictional force. So this is tension, normal force, tension, frictional force, and our weight. And remember, I said here we have FG perpendicular and FG parallel. Going to need it since we are calculating. And then we will start with the forces that are acting on 4 kg. And always remember, F net or net force is equals to MA. And then also all the forces that are acting on the 4 kg block are, okay, let's say down the incline is negative and up the incline is positive. Or you can say the direction of a motion is positive since the motion is going up the incline. And forces that are acting on the 4 kg block, we have tension minus that are acting parallel to the plane. So it's T minus, since the frictional force is opposing the motion, is minus Fk and also FG parallel is opposite the motion, so it's minus FG parallel. And we equate our equation by saying MA is equals to T minus FK minus FG parallel. And we're going to calculate our FG parallel the same way we calculated our weight perpendicular, just changing the trig ratios since this one is opposite to the angle, meaning FG parallel is equals to FG parallel is equals to weight, or we can say FG sine theta decrease. And our weight for the 4 kg block is 4 times 9,8 times sine theta. You can either calculate it on your side and then come with the answer here. You can just write the whole formula here. So now we have MA equals to T minus FK minus, I said it's weight sine theta. And our mass is 4. We don't have acceleration. We also don't have T. We are calculating T obviously. And then negative FK. They said the frictional force for a 4 kg block is 10 newtons. Okay, it's 10 minus, and then our weight is 4 times 9,8 sine 30 degrees. When calculating a problem like this, what you can do is you come to your question and you write all the values that you have. For example, here we have our FK, and we don't have a tension, okay, because our FK is 10 for the 4 kg block, and then our tension is unknown. Our acceleration is also unknown, and also weight parallel is equals to weight sine 80 degrees, and then you can calculate it here and then write to answer. And then we have parallel force acting on an object, or these are the forces. So, and then you now know that you don't have T and you don't have A, but this is just additional information. If and let's continue, and now we're going to say 10 minus all this. So here it's negative, okay, it's going to be negative 10 minus 4 into 9,8 sine 30 degrees. Make sure your calculator is in degrees, equals to negative 29,6. So we have 4A equals to T minus negative minus 29,6. And this is our equation number 1. Then now let's go to our 1 kg block, and we're still going to use our free body diagram, and we're going to say F net our net force is equals to MA. And also our F net is equals to, okay, set down the plane or opposites, the motion is negative, so this force is acting in the direction of motion is positive. Fa minus our tension and also minus our weight parallel, and also we have a frictional force minus Fk. Okay, and then we say Ma is equals to Fa minus T minus weight parallel minus Fk. And then our mass here is 1, so we just left with A equals to force applied, it was 40 newtons from the diagram. Here it is. Here is the force applied, 40 newtons. And what, and then, okay, we have 40 newtons minus, okay, I can erase this one, and then it's minus tension minus what with parallel. With parallel, the same as if the parallel, so it becomes correct by saying weight sine d decrease, since it is the same plane, minus our frictional force was 2,46, which we calculated on the previous question. And then now we have, okay, our weight here, it was going to be 1 minus 1 into 9,8. So we're going to say A is equals to, we can say it's 40 minus all these numbers, so it's going to be 40 minus 1 into 9,8 sine d decrease minus 2,46 equals to 32,64. So it's 32,64 minus t, and this is our equation number 2. So here again, we're going to substitute this sum into here where we have A, since we are looking for the tension. Okay, or else we can say, you can divide by 4 here and make 8 of the formula, and we are left, oh, dividing with 4, we'll be left with A equals to T minus 29,6 all over 4. And when we equate our equation, so it's 32,64 minus T equals to T minus 29,6 all over 4. And when we solve for T, and then we first start by cross multiplying, say 4 times 32,64 should be 32,64 times 4, 830,561 130, comma 5 6 minus 4 times t is negative 4. T equals to t minus 29, comma 6. We're still solving for t. We make t solid formula. Okay, let's transpose this t to the side, and then we're going to have, to our right hand side, we will have t plus 4t, and on this side it will be 130, comma 5 6 plus 29, comma 6. So we have 5t and also 130 plus 5 6, oh sorry, comma 5 6 plus 29, comma 6 is equals to 160, comma 16. It's 160, comma 16 over 5 over 5. So our t is equals to 160, comma 16 divided by 5 is equals to 32,032. 32,032. So our tension, therefore, our tension is equals to 32,032 newtons. This is our answer. So our today's session ends here, guys, and if you come up, if you have a problem on any of this equation, you can contact us on our Facebook page, which is Net Functions, or you can comment on the comment section below. And even if you have a question based on Newton's laws, you can ask it on our Facebook page. Thank you.